Assalamu alaikum, everyone. Let's wait for the others to join the class, then we'll start, inshallah. Within 5 to 6 minutes, we'll start with the class. Assalamu alaikum, everyone. My name is Muhammad Luqman, and currently I'm teaching in City School and Garrison. And my previous background, I spent 4 years in ATSN College to teach O levels and A levels chemistry. So today I'm here to tell you about some tricks to do past papers questions like P1, which you are going to appear in the next couple of days. So our main focus will be on your problems and on difficult questions. So number one, if we see the previous year graphs, this is a graph of 2020, October, November. So major portion in 2020 that was for organic chemistry. In or from the organic chemistry section in paper one, there are 7 to 8 questions, which is a very big percentage for P1 in organic chemistry. Out of 47 to 8 questions that come from organic, and last questions from 32, even 33 to till 40 number, till that is for organic chemistry. And then after that, you will get air and water, which is very easy for you guys. So I'm not going to discuss air and water. My focus will be on organic chemistry and a little bit, or this is a portion for electrolysis. And for the electrolysis, there are 3 to 4 questions that comes from electrolysis and a little bit from the periodic table. So 2 to 3 questions from the periodic table. So my focus for today's class, because we have only 2 hours to discuss your problems, so I'll be focusing on organic chemistry and for electrolysis, and some part of periodic table I'll discuss in today's class. Some more students, they are joining. Some of the students, they are requesting to discuss mole. Okay, so first 20 to 30 minutes I'll spend on mole. Then I'll move towards organic chemistry and then electrolysis and periodic table. Okay, let's start with the mole. You know very well about moles. You have learned about 3 formulas of mole. That was, number 1 was mole is equal to mass in gram and over mr. Now for mole, there are 2 types of questions that come from the mole in P1. Number 1 is, first is with the percentage composition and mass composition. For this, we use a formula that is, this is a formula to find out percentage composition, that is, for percentage is equal to AR of an element, which is relative atomic mass, multiplied by number of atoms over MR, or relative molecular mass, multiplied by 100. This is a formula which is used to find out percentage composition of an element in a compound. And second is with the mass composition. Mass composition is, this formula is same for mass composition, but there is one difference for mass composition, that is AR multiplied by number of atoms over MR, or molecular mass, into given mass. Instead of 100, for mass composition, you will multiply with the given mass. Just I'll give one example for percentage composition and mass composition. For example, we have this sodium carbonate. Na2CO3, how we can find out percentage composition of carbon in sodium carbonate. For this purpose, first of all, you will find out MR of sodium carbonate. To get MR of sodium carbonate, you will get AR from the periodic table. For sodium, it is 23, carbon is 12, and oxygen is 16. So MR for sodium carbonate is 16 into 3, this is 106, this is the MR. To find out percentage of carbon in sodium carbonate, you will use AR of carbon, which is 12, multiplied by, there is only one atom in sodium carbonate molecule, so 12 multiplied by 1 over MR. MR is 106, multiplied by 100, so this is your answer for percentage composition. In a similar way, you can also find out percentage of sodium. To find out percentage of sodium, that is 23, and there are two atoms in sodium carbonate, and 23 times 2 over 106 multiplied by 100. So this is a percentage of sodium in sodium carbonate, and this is a percentage of carbon in Na2CO3. So this formula is used to find out percentage composition. Mainly, examiner asks you about percentage of nitrogen in different compounds. Percentage of nitrogen in, for example, urea or any other nitrogenous compound. NH2 twice CO, this is urea. To get percentage of nitrogen in urea, you will use MR of this compound, which is 14 plus 2 times 2, because there are two NH2 molecules, plus carbon is 12 and 16. So this is the MR. To get percentage of nitrogen in urea, that is 14 times 2 over MR multiplied by 100. This is the formula which is used to find out percentage composition of nitrogen in urea. Okay, in a similar way, you can also find out mass composition. For mass composition, you will use same formula. For example, there is 200 grams of copper sulfate. How we can find out mass of copper in 200 grams of copper sulfate? You will use this formula. For mass composition is equal to AR of copper, which is 64. Number of atoms, 1 over MR 160 multiplied by 200. Now here you can see, instead of 100, we are multiplying with the given mass, which is 200. So this is a mass in grams of copper in copper sulfate of 200 grams. So this formula is used to find out percentage composition. Next thing is with the type of formula, that is empirical formula and molecular formula. Empirical formula and molecular formula or chemical formula. Empirical formula definition, you know very well, that is empirical formula. It's the simplest formula which shows ratios of element in our compound, which shows simplest formula, which shows simplest ratios of element in our compound. How you can get simple formula from the, if molecular formula is given to you. For example, this is C6H12. How we can get empirical formula for this C6H12, that is hexane? You'll write elements, carbon and hydrogen. There are 6 carbons in this molecule and 12 hydrogens. Just say their ratio, you have to simplify their ratios. This is 6:12. You can make it 1:2. So your empirical formula for C6H12, it is CH2. In a similar way, you can also get empirical formula for this is C4H8. Again, this is carbon and hydrogen. This is 4 and 8. You can simplify them by using 1:2. So empirical formula is CH2. So C4H8 and C6H12, they have same empirical formula. So for a compound, for 2 compounds, 2 or more compounds, molecular formula will be different, but empirical formula can be same for 2 or more compounds. So you should focus on molecular formula, but examiner will ask you about how we can get empirical formula. So you will simplify the ratios of element in a compound. Another example, this is a compound which is suppose C10H22. How we can simplify this? The carbon and hydrogen. This is 10 and 22. We'll simplify this thing. That is 5 and 11. So empirical formula for this compound is going to be C5H11. This is the empirical formula. So what you have to do to get empirical formula from the molecular formula, just you have to simplify the ratios of element in a compound. Okay, next is how you can get empirical formula if percentage composition is given to you. Formula if percentages are given. When percentages are given, you will use this method. For example, this is a compound consists of carbon, which is 60% carbon and 32% is oxygen and rest is hydrogen. How we can get empirical formula from these percentages? So to get empirical formula, first of all, you will write their elements, carbon, hydrogen, and oxygen, write their percentage composition. Percentage is 60, oxygen is 32, and to get percentage of hydrogen, you will use 100 minus 60 plus 32, with this is 8%. So hydrogen, it is 8%. At first step, you will divide all the percentages. Instead of percentage, mass in gram can also be given in the question. So at first step, you will divide all the percentages with the AR of respective element. AR of respective element is carbon over 12, 60 over 12, hydrogen is 1 and 16, 32 over 16. So this is your first step. So answer for this, that is 8 and 2. So the ratios are 5, 8, and 2. At second step, you will divide all the numbers with the smallest number. Divide all the numbers with the least number. Least number in this compound, that is 2. So you will divide with 2, 2, and here 2. So your answer, you are getting 2.5. This is 4 and 2. This is your simplest ratios you are getting to get empirical formula. But keep in mind, number of atoms cannot be in decimal number, or in points cannot be in empirical or molecular formula. So you can convert, or you will convert into whole number by multiplying all the numbers with 2. So your answer is going to be same, C5H8, and oxygen is 4. So empirical formula is C4H8 and O4. This is empirical formula if percentages are given to you. Rest you can use same method. First is you will divide with the AR of respective element, and second is you will divide all the numbers with the smallest number. That is your empirical formula. But in P1, examiner never asks you about molecular formula from the empirical formula. From the empirical to molecular formula, examiner never asks you about this. So I'm not going to discuss anything regarding this. Okay, you will get recording of this class on the YouTube, on the GreenHall online chapter. Now, next thing is with mole, how you can find out mole. To get number of mole, we use 3 formula. Number 1 is mole is equal to mass in grams over mr or ar, or in simple words, molar mass. Molar mass is mass of 1 mole of a substance, that is molar mass. Second formula is N is equal to C into V. C stands for concentration, and unit for concentration is mole per dm cube. and V stand for volume, and unit for volume is cm cube or dm cube, but most of the time volume is given in cm cube. So every time you have to convert the cm into dm cube. So this is going to be n is equal to, in simple words, volume over 1000, most of the time to find out number of mole. This formula is used when concentration and volume of a liquid is given to you. And this formula is used when mass in gram is given to you. And the last thing is for gases, mole is equal to volume of gas over molar gas volume, which is 24 dm cube or 24,000 cm cube. So these three formulas which are used to find out number of mole, if you know these three formulas, you can do questions of mole very easily. And next is, for example, here you have, this is a reaction between N2 plus H2, 3H2, you are getting ammonia, 2NH3. Now, question is, how much ammonia should form when 60 kg of nitrogen is reacting with excess of hydrogen? How much ammonia should form, NH3 forms, if 60 kg of nitrogen is reacting with excess of hydrogen? So now hydrogen, it is in excess. So excess reactant is ignored in our chemical reaction. So this is the excess reactant. Excess reactant is ignored. We are not going to do any calculation for this excess reactant. We're only using this 60 kg of nitrogen. Now focus on this equation. This is a balanced chemical equation. When balanced chemical equation, you will do calculations on this. What's the number at this point? With the nitrogen, there is no number. So it is 1. This is 3. And here 2. So these numbers, they are telling you about molar ratio. It means 1 mole of nitrogen is reacting with 3 mole of hydrogen to form 2 mole of ammonia. So I'm going to repeat this statement again because it's very, very important concept. Here you have number, which is 1. So it's indicating 1 mole of nitrogen is reacting with 3 mole of hydrogen to form 2 mole of ammonia. Now find out number of mole of reactant which is given to you. This is 60 kg of nitrogen, and other is in excess, so we will ignore for hydrogen. So our main focus will be on the nitrogen. So how we can find out mole for 60 kg of ammonia? This is 60 kg over mR. mR of nitrogen is 28. So these are the number of mole. Now try to find a number of mole for this 60 over 28. This is 2.14. Now apply the molar ratio. 1 mole of nitrogen is giving you 2 mole of ammonia. Now, if you have 2.14 mole of ammonia, how much ammonia should form? So if this is going to be 2.14 times 2, this is 4.29 mole of ammonia will form. Now, how can you convert this mole into mass in gram? You'll use again same formula, mole is equal to mass over mR. So mole you have, which is 4.29, mR for ammonia is 17, and you will get mass in grams. So simply you will multiply 4.29 into 17. So this is in kgs. Keep in mind, I'm dealing with the kg. I haven't converted this kg into gram. So that's why your answer will be in kgs. So 72.86 kg of ammonia will form when 60 kg of nitrogen is reacting with hydrogen to form ammonia. mR for This is not the MR for hydrogen. This is the MR of nitrogen. Mass for nitrogen is given for 60 kg of ammonia. Mark 4, you ask this question. This is not H2, this is N2. 14 times 2, this is 28. Now, in a similar way, one more question. This is calcium is reacting with HCl to form CaCl2 and hydrogen gas and H2 gas. Now, question is in the exam, for example, how much gas should release if 10 gram of calcium is reacting with excess of HCl. I'm giving you 2 minutes to do this question. This is a balanced chemical equation. And AR for calcium is 40. I'm telling you this. And for chlorine is 35.5. And hydrogen, it is a gas. Find out volume of hydrogen gas when 10 gram of calcium is reacting with excess of HCl. I'm giving you 2 minutes for this. So now I'm going to give you a hint to do this question. First of all, identify the molar ratio. Molar ratio between calcium and hydrogen is 1. Calcium chloride, this is also 1. You have to find out volume in dm cube, not in grams. This is not a mass. You have to find out volume. So at first step, you will find out number of mole of this calcium. Calcium is 10 gram. And AR of calcium is 40. So 10 over 40, number of moles are 0.25 mole. Now, ratio between calcium and hydrogen is 1:1. So 0.25 mole of calcium will produce equal mole of hydrogen, that is 0.25. So you will multiply with volume, molar gas volume, that is 24. So 0.25 into 24, this is going to be, this is 6.0 dm cube of hydrogen gas will release. Aziz, I asked you to find out volume of a gas, not mass in gram. Yes, your answer is correct if examiner asks you to find out mass in gram. Now, another thing about limiting reactant and excess reactant. Limiting reactant and excess reactant. Limiting reactant, it's a reactant which has less number of mole than required. It's a reactant which has less number of mole than required. And we use limiting reactant is used to predict the moles of the product. Limiting reactant is used to predict the moles of product. And excess reactant, it's a reactant which has more number of mole than required. This has more number of mole than required. And excess reactant is ignored in the calculations. We don't use until unless examiner asks you about the remaining reactant. So this is ignored in the calculations. So our major focus should be on the limiting reactant. Now, how we can identify limiting reactant and excess reactant? This is a question. For example, here we have NaOH plus H2SO4. Product is Na2SO4 plus H2O. Here you have question 1.5 mole per dm cube of 30.0 cm cube NaOH is reacting with 1.5 mole per dm cube of 20.0 cm cube H2SO4. Now, question is how much Na2SO4 should form? How much Na2SO4 forms? And this is in grams. Yeah, find out mass of Na2SO4. Mass of Na2SO4 formed. So at first step, that is you have to predict their molar ratio. This is a balanced chemical equation. Now 2 moles of NaOH, they are reacting with 1 mole of sulfuric acid. Now you will identify limiting reactant and excess reactant. For this purpose, you will find out number of mole of any first quantity we are using. For example, this is NaOH and this is for sulfuric acid. So at first step, you'll find out mole of NaOH 1.5 into 30 over 1000. How many number of mole we have for NaOH? So number of mole for NaOH, it is 0.045, not 50. Marco, you have to convert this cm cube into dm cube. So that's why you have to divide 1.5 into 30 over 1000. So this is 0.04. Now apply their molar ratio. For 2.2 moles of NaOH, 1 mole of sulfuric acid is required. For 0.045, how much sulfuric acid is required? So that is going to be half. 0.045 divided by 2. So this is going to be 0.0225. So these are the number of mole of sulfuric acid required to react completely with the sodium hydroxide. Now, how much sulfuric acid is given to you? So find out number of mole for sulfuric acid. These are the number of moles you have, 1.5 into 20 over 1000. So this is going to be 1.5 into 20 divided by 1000. So this is 0.03. So now you can see required amount is 0.025. But you have 0.03, which is given in the question statement. You are getting this sulfuric acid. So 0.025, it is less amount than you have. So sulfuric acid is going to be excess reactant, and sodium hydroxide, it's a limiting reactant. Because you need 0.025 to react completely with the sodium hydroxide, but here you have 0.03, which is more than our requirement. Now you are going to apply molar ratio of NaOH. So what's the ratio between NaOH and sodium sulfate? It's 2:1. So number of mole of sodium sulfate forms, that will be half of NaOH. So this is going to be 0.0. 0.0225. So this is a mole. If mole is given to you, you can find out mass in gram very easily by multiplying with the MR of sodium sulfate, which is 23 times 2 plus 32 plus 64. So this is the mass in gram of sodium sulfate forms in a reaction. I hope you know very well. You got this point how to find out limiting reactant and excess reactant. And one last question, one last topic of this mole, that is how we can find out percentage yield. To find out percentage yield, we use this formula. Percentage yield is equal to actual yield over actual yield. This is always given to you in the question, over theoretical yield multiplied by 100. This is the formula which is used to find out percentage yield. Now, question related to this percentage yield. This is a question. Now, again, N2 plus 3H2. This is a product which is 2NH3. Question is, find out percentage yield if 60 kg of H2 is producing 90 kg of ammonia. Find out percentage yield. Now, very first step, you will find out molar ratio. Their ratios are 1:3:2. And which thing is given to you? That is 60 kg of hydrogen is giving you 90 kg of ammonia. This 90 kg of ammonia is your actual yield. And you will get theoretical yield from the balanced chemical equation. This theoretical yield you will get from the balance equation by using calculations. That's what we call it theoretical yield. At first step, you'll find out number of mole of this hydrogen which is given to you, because this nitrogen is in excess. So we are not going to do any calculation on this nitrogen. So here you will start with hydrogen, 60 kg of hydrogen. You can find out mole 60 divided by 2. So this is 30 mole. Now 3 moles are releasing 2 mole, and 30 mole of hydrogen will release how much ammonia? So that is simple ratio, 3:2. So 30 mole will release X mole of ammonia. So X is going to be 30 into 2 divided by 3. So this is there are 20 moles of ammonia should form. So this is 20 moles. You can get from 20 moles of ammonia, that is mass in kg. So 20 multiplied by MR of ammonia, which is 340. This 340 is your theoretical yield. This is theoretical yield. Percentage yield, now you can find out by using this, is 90 kg actual yield. 340 is theoretical yield. Now percentage yield will be 90 over 340 into 100. This is your percentage yield. So this is 90 divided by 340 multiplied by 100. It is 26.47% yield. This is for ammonia. Iman Fatma, you are asking, sir, hydrogen ka ratio to 3 hai na? Yes, this is 3:2. This is 3:2. 30 mole will give you how much ammonia? So you will apply cross multiply. So when you will cross multiply, value of X is 20 mole. Then you will multiply with the MR of ammonia to get mass in gram. That is your theoretical yield. I hope you got this concept of how we can use ratio. Now, one tricky question from the past papers. This is nitrogen and oxygen. They are forming. Now take your screenshot, Armagan Chaudhary. Okay, next is, this is a question from the past papers. N2 and O2, they are forming NO2. This is 2 and O2 to make it balance. You will multiply here. So my question is, how many moles of NO2 forms if 2 moles of nitrogen is reacting with 2 moles of hydrogen. 2 moles of nitrogen is reacting with 2 moles of oxygen. Now keep in mind limiting and excess reactant. There are equal moles of nitrogen and oxygen. How much NO2 should form? You have only 1 minute for this. For this, you will start with a molar ratio. What's the number with the nitrogen and oxygen? This is 1:2. First of all, you will identify limiting reactant and excess reactant. This is how many moles of nitrogen you have. This is 2 moles of nitrogen and 2 moles of oxygen. So for 2 moles of nitrogen, how much oxygen is required to react completely with 2 moles of nitrogen? This is 1:2. For 2 moles of nitrogen, you need 4 moles of oxygen. You need 4 moles. This is your required amount. But how much you have in the question statement? That is 2 mole of oxygen you have. So which one is limiting reactant? Required is 4, but you have only 2 moles of oxygen. So this oxygen is a limiting reactant. This oxygen is limiting reactant. Reason for this is 4 mole you required, but you have only 2 moles. So this oxygen is a limiting reactant and nitrogen is excess reactant. So excess reactant you will ignore. We are not going to use any 2 moles because this is in excess. Now, how many moles of oxygen you have? That is 2 moles of oxygen you have. What's the ratio between them? 2 and 2. So if I simplify this 2:2, that is 1:1. So 2 mole of oxygen will release 2 mole of NO2. This is your answer, not 4 mole. Roshan Fahad, this answer is wrong because you haven't applied limiting and excess reactant. So this nitrogen is excess reactant. So we are not going to use this 2 moles of nitrogen. We will ignore this thing. So 2 moles of nitrogen and 2 moles of oxygen will release 2 mole of NO2. Now, one more question. This is a reaction between CH4 plus O2. They are forming CO2 and H2O. To make it balanced, you will multiply 2 and 2. Now, how much volume of carbon dioxide should form? Volume of CO2 gas forms if 10.0 cm cube of methane is burned in 200 cm cube of oxygen. Now you need to find out volume of this carbon dioxide. Now try with this question. Jessica, Javed, you asked for 17 because 2 moles of NH3 are formed. But you don't need to multiply with the molar ratios. Mole which you are getting from their molar ratio, you will use those mole, but you cannot you cannot use those number of molar ratio which you are to get MR. G, how much carbon dioxide gas should release upon combustion of 10 cm cube of this methane? If you're wrong. Now for this is, first of all, apply molar ratio, 1:2. This oxygen, it is already in excess reactant. How we can determine why it is excess reactant? You can perform calculation because they are gases. So for this, you don't need to find out number of mole. You can directly apply molar ratio for each. For 10 cm cube of methane, you need 20 cm cube of oxygen. So this is your required amount, but you have 200 cm cube. So this is an excess reactant. Oxygen is excess. You will use only limiting reactant. So between methane and carbon dioxide, it's 1:1. So between methane and carbon dioxide, it's 1:1. So 10 cm cube of methane will release 10 cm cube of carbon dioxide gas. That is 10 cm cube, not 9.98 cm cube. Again, question is C4H10 plus O2, it is forming 4CO2 and 5H2O. Now, question is how much gas is released or how much carbon dioxide is formed if 10 cm cube or 20 cm cube of butane is burned. C4H10 is burned in excess of oxygen. So again, you will apply simple ratios. 1:, this is 13/2, 1:4. So the ratio between butane and carbon dioxide is 1:4. If you're burning 20 cm cube, so 20 cm cube of butane will release 80 cm cube of carbon dioxide. So when volume or gases are given to you, you don't need to find out number of mole. You can directly apply molar ratio on the volume of gases. So this was about mole. Now, any confusion regarding this mole, you can ask me in the chat box. After that, I'll move towards next topic, that is organic and electrolysis. Jasha Shahid, no, you cannot apply percentages, apply ratio with the percentages. You can apply ratios only number of moles. Armagan, you asked me limiting better for limiting reactant. Recordings देख लेना. अच्छा, for volume, simple, you will apply molar ratio. This is molar ratio 1 butane is reacting with excess of oxygen to form 4 mole of carbon dioxide. So this is carbon 1 ratio 4. So directly you will apply 20 cm3 when you will burn 20 cm3. So this is 1 ratio for 20 cm3 will release X. X is going to be 20 times 4, 80 cm3 of gas will release. Now, so this was about limiting reactant and excess reactant and mole. Still, if you have any confusion regarding this mole or questions, you can ask me in the chat box. I'm giving you 2 minutes for this. Yes, Armghan always use limiting reactant because excess reactant is ignored and excess reactant will remain after the reaction. So you cannot use excess reactant, always use limiting reactant. Jasha, you asked me for 2018. Can you do a past paper question from 2018 about moles? Better send me variant and tell me about the which in which season, October, November, or May, June. At the end of our class, I'll give you some time to discuss your problems. So now I'm going to move towards organic chemistry. So in organic chemistry, this is a major portion. Now, this thing you have to memorize most of the time, students, they don't know which fraction what is the use of a specific fraction. So this table you should keep in mind that at first step, you will get refinery gas, petrol, because the one which has lower boiling point, fraction which has lower boiling point will come first, or you will get collect from the top of a fractionating column. And the one which has highest boiling point, you will get from the bottom of this fractionating column. You will get from the bottom. So these are the uses. Number one is LPG is used for LPG gas, and next is for now, second is petrol, which is used for vehicles or car. Naphtha, it's a main ingredient for many chemical industries. It is used to make different chemicals. Kerosene, it is used for jet fuels, diesel, and these are the uses of different fractions which you will get from the, which we separated by using fractional distillation of crude oil. Okay, Jaisha, I got your question. Uh, at the end of the class, I'll discuss this question with you. Okay, next is hydrocarbons. Hydrocarbons, the compounds which are made up of carbon and hydrogen only. Compounds which are made up of carbon and hydrogen only, we call them hydrocarbons. So there are two types of hydrocarbons. Number one is alkane and second is alkene. Alkanes, they are saturated hydrocarbon. Alkenes, they are unsaturated hydrocarbon. What does it mean by saturated? Saturated means there is no double bond. All the carbons, they are attached with each other through a single bond. So they are saturated, and unsaturated, they have at least a double covalent bond. At least a double bond between carbon and carbon atoms. So they are known as unsaturated. Isomers, they are the compound which has same molecular formula but different structural formula. They are known as isomers. I'll discuss this thing in detail, how you can identify different compounds which have same molecular but different structure. So isomers, they are the compound which have same molecular and same or different structural formula. So in the exam, no one is going to ask you about the definition of isomer, but they will ask you about isomer. They will give you different compounds, and examiner will ask you about isomers. So how isomers are formed? For example, this is a compound. Here you have butane 1, 2, 3, and 4. This is butane. Molecular formula for this butane is C4H10. How we can make this make isomer of this compound? I will remove one carbon from any terminal carbon from this chain. Either you can remove from this side or you can remove from this side. I'm going to remove from this side. If I remove this carbon, there will be 3 carbon chain left. And I'll attach the carbon which I removed to the central carbon. So this has same formula, which is C4H10, but structure is different. So they are isomers. But if I rotate this single covalent bond, keep in mind single covalent bond can rotate. These are the identical molecules. This is molecule 1, molecule 2, and molecule 3. So they are number 1 and 3, they are identical. And examiner can also do this thing 1, 2, and 3. So again, single covalent bond, your terminal पे था, that has rotated downward. Both the carbons, they have rotated downward in number 4. So number 1 and 2, they are isomers of each other, but number 1, 3, and 4, they are identical molecules. Armghan, you asked me why not at any other carbon bond? Because if you rotate, if you remove this carbon, there will be 3 carbon chain, and you are going to attach at the center. But if you attach on terminal carbons, out of these 3 carbon, number 1 or on number 3 carbon, that molecule will be the same. So there will be no isomerism. So iso compounds which have different molecular formula, so different structure formula and same molecular formula. So all the things, they have same molecular formula, but number 1, 2, 1, 3, and 4, they have same structure. Fatima, you don't need to draw H. It's understood when you are going to show a bond, it means there is hydrogen is attached. So most of the time we don't need to show this hydrogen. So this was about isomers. There's only 4 carbon chain that is in your syllabus, so I'm focusing on this number 4 carbon. So this is, name for this is 2-methyl, because if you will see for number 2 compound, this is a branch, this is a branch, and this is your main chain. In a main chain, there are 3 carbons. This is carbon number 1, 2, and 3, and a carbon which has 3 carbons in a chain that is known as propane. Now it has a branch, so branch it is on number 2, and 1 carbon branch is known as methyl, and methyl is attached on number 2. So name of this compound is going to be 2-methyl propane. Hashir Khan, I hope you got it. And compound C4H10, which are 4 carbons in a chain, that is butane. That is butane. And now you can see they have different names. So this was about isomers. So again, you should keep in mind when you are going to draw isomer, if I draw this compound 1, 2, and 3, 1, 2, 3, and this is 4 carbon. Now, is it isomer or identical molecule? This is number 4 carbon. So this is considered as a single chain. You start this chain from this point, 1, 2, 3, and 4. There are 4 carbons in a chain. So this is identical molecule. Abdullah, this is not the time to learn the name of these isomers. Just at this moment, you should focus on how isomers are formed, which molecule they are isomer, because there is only one paper for you, that is P1. So in P1, examiner never asks you about the name of isomers. So this was hydrocarbons and isomers. Isomers which have only number 1 or 2, they were isomers. 1, 3, 4, and 5, they are not isomers of each other because they have same structure. So here, these are the physical properties of hydrocarbons. You don't need to memorize this thing. Now let's move towards combustion reaction. All the hydrocarbons, they burn in excess of oxygen to form carbon dioxide and water. For example, this is methane. If you burn with oxygen to form carbon dioxide and to H2O, this is a combustion reaction. And if you see total molecules of this product, that is 1:2. So if you burn 1 mole of methane, only 3 moles of product you will get. So each time when you burn a hydrocarbon, product is going to be carbon dioxide and water. If you burn C3H8, and it is going to form carbon dioxide and water, to make it balanced, you will multiply 3, and this is 4. Plus oxygen, this is 3 to the 6 and 4, 10, so 5O2. So this is a combustion reaction. And in a substitution reaction is, for example, this is a methane. Methane is reacting with chlorine gas, Cl and Cl gas. In a substitution reaction, one hydrogen forms a bond with chlorine. This is HCl. Hydrogen and chlorine, they react. They will form this chlorine and hydrogen, that is HCl. And this methyl will form a bond with this chlorine to form chloromethane. So this is known as substitution reaction. Incomplete combustion releases carbon monoxide. This is complete combustion when oxygen is in limiting quantity. So product is carbon monoxide and water. And even carbon solid is also formed. Soot is also formed when oxygen is a limiting reactant. So this is incomplete combustion. But you don't need to focus on incomplete combustion. Consider this oxygen is, because oxygen is 21% oxygen is present in the air. So oxygen is always in excess quantity. Now, for substitution reaction, now my question is, if this is a CH3Cl, in this compound substitution can also occur to remove other hydrogens. So this is also further, this is known as substitution. There's 2 moles of chlorine. If they react with 1 mole of methane, they will form CCl2. There was one question in past papers. For example, here, if you see, this is methane, CH4, reacting with Cl2. The product is CH3Cl plus HCl. But if you're using, because all the rest of the hydrogen, they can also be substituted with the chlorine. So when you are using 2 moles of chlorine, so 2 moles of, or 2 molecules of hydrogen will be substituted by the chlorine to form 2HCl. So each time when 1 mole of chlorine is reacting, there will be 1 mole of HCl and 1 mole of methyl chloride. And if 2 moles of chlorine is reacting, then 2 moles of CH2Cl2 will form. But if you are reacting with 3 moles of Cl2, then product is going to be CHCl3 plus 3HCl. So you should focus on how many moles of chlorine they are reacting in the question. Next is with addition reaction for alkene. Alkenes give addition reaction because of double covalent bond. Now, in addition reaction, number 1 is it reacts with, this is alkene. One more thing I want to tell you. If this is this CnH2n plus 2, this is formula for alkane, and CnH2, and this is for alkene. Alkenes, they are unsaturated. Now, alkanes, they are saturated. Now, if you see C2H6 and this is C2H4, if you double the number of carbons, that is number of hydrogen, that will happen in alkene. If there is an alkane times 2 plus 2, that is alkane. For example, if there is an alkane that has 3 carbons, so hydrogens will be 3 times 2, that is 6. Then add more 2 hydrogens. So this is C3H8. This is for alkane. And if there is C3 and H is double than the carbon, that this is for alkene. So you should keep in mind, you can differentiate if formula is given to you, you can differentiate which one is for alkane and which one is for alkene. So carbon number doubles, then plus 2, that is if number of hydrogens, so this is going to be alkane. But if our number of hydrogens are exactly double than the carbon, that is for alkene. Now, chemical properties of, now here you have addition reaction of alkane. So I'll discuss later on. I'll discuss these questions. Alkanes are saturated compounds containing carbon and hydrogen only. Structures 1, 2, 3, and 4 are saturated hydrocarbons. Which pair of structures are isomers? Now question. Now, if you see, this is, now check their molecular formula. Molecular formula, this 1, 2, 3, 4, 5, and 6. This is C6H14. 1, 2, 3, 4, 5, and 6. This is again C6H14. This is C6H12. So this cannot be. And number 4 is 1, 2, 3, 4, and 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. So this is C7H16. So which two compounds they are isomers of each other? So compound 1 and 2, they are isomers of each other. Now, can you try with this? Do these two questions, question 1 and 2, which statement about homologous series of alkane is correct? Homologous series, they are the compound which has same functional group, same molecular formula, and trend in physical properties. They are known as, this is known as homologous series. So very first one, alkanes are unsaturated. No, they are saturated, so the statement is wrong. And alkenes will have general formula. Alkanes will all have general formula CnH2n. No, CnH2n plus 2. So the statement is wrong, A and B. Boiling point decreases as a number. No, boiling point increases. Liquid alkanes become more viscous. Their viscosity, their thickness increases as a molecular mass. Yes. So as the carbon number increases, their viscosity also increases. So your answer is, for this question, is D. Nail Amir, sorry, we cannot do extraction of metals because of shortage of time. Now, which compound has the empirical formula with the greatest relative for molecular mass? Now, in this question, he's asking you about two concepts. Number one is empirical formula with the greatest formula mass. First of all, you will find out their empirical formula. So empirical formula for this is CH3. This is C2H5. This is CH2 and CH. Now, this compound C2H5 has greater empirical formula, and their mass is 2 multiplied 12 plus 5. So this is 29. This is 13, 14, and this is 15. So your answer is for B. First of all, you will get empirical formula for all these compounds, and then you will find out their mass. Now move on question number, again, this is question 1 and 2, which statement about vegetable oil and margarine made from its correct. Vegetable oil is unsaturated, keep in mind. It has alkene. Margarine is alkane, it's saturated hydrocarbon. So margarine has a higher melting point. Yes, margarine is semi-solid at room temperature, but oils, they are liquid at room temperature. So both are liquids at room temperature? No. Both occur naturally? No. Oils occur naturally, but margarine, it is synthetic. Vegetable oil has fewer carbon double bond in than margarine. Margarine does not has any double bond. Vegetable oils, they are polyunsaturated. And when ethene reacts with steam to form ethanol, which type of reaction takes place? That is addition reaction. Ethene, C double bond C, when you add water into it, H and OH. With one carbon, hydrogen is attached, and other carbon, OH is attached. So this is addition reaction. Now, can you try for this question? The diagram shows structural formula of an organic compound. Which statement about this compound is correct? So it is saturated hydrocarbon. Yes, because all the carbons, they have single covalent bond. So it is saturated. Rest of the options, they are wrong. Now let's move towards alkene. Alkene is, wait, sorry. Now, which statement about organic compound CH4, C2H4, C2H6 is correct? Now you can see C3H8, is it alkane or alkene? Because hydrogen's number, they are more than the carbon number. If you double the carbon number and then add 2, so this is an alkane. C2H6, this is also an alkane. C2H4, this is alkene, because hydrogen number, they are double than the carbon number, so CH4 is alkane. Now only C2H4 and C decolorize. No, only C2H4 can decolorize. So this statement is wrong. All are no, they all are hydrocarbons because they contain carbon and hydrogen only. This structure represents the isomers of a butane. Butane is, this is a butane which has 4 carbon. Which compound shows isomers? Yes, again, you will remove this carbon and you will attach with the central carbon. So your answer is C. Now, which formula represents an alkane? Last question. Then we'll move towards alcohol and acid, and then we'll do polymers. So carbon number doubles, then add 2, that is for alkane. Carbon and hydrogens are double than carbon, so this is alkene. 31 times this is, so this is less number of hydrogens than carbons. So this is again less number of hydrogens. So they all are polyunsaturated, and this is the only compound which is saturated or alkane. So this was about alkane and alkene. Now let's move towards alcohol and carboxylic acid. Alcohol, it has OH functional group, and carboxylic acid, it has CO2H, or you can write COOH functional group. So now the properties of alcohol and carboxylic acid. Very first thing is combustion of alcohol. When you burn CH3OH with oxygen, what should be product? This is going to be CO2 and 2H2O. And to make it balanced, you will multiply with 2. So again, when you burn alcohol, product is going to be carbon dioxide and water. Second chemical property for alcohol is oxidation of alcohol. For oxidation of alcohol, we use oxidizing agent that is acidified, few drops of acid with KMnO4. At your level, you can use KMnO4, but in A levels, we don't use KMnO4 or K2CR2O7, potassium dichromate. KMnO4 colors change from purple to colorless, and K2CR2O7 changes color from orange to green. This is a color change. So alcohols, they are oxidized when you do alcohol with oxidizing agent, that is KMnO4, in acidic medium. This is as a reactant product is going to be carboxylic acid. So this reaction is also used to produce carboxylic acid as well. If you oxidize ethanol, C2H5OH, or F1 to this is OH, if you react ethanol with acidified K2CR2O7 under reflux, then product will be carboxylic acid, which is COOH and H2O. So this is a product from ethanol. Product is going to be ethanoic acid. Or which alcohol you will use to prepare propanoic acid? Now, what should be answer for this? Which alcohol you will use to produce propanoic acid? So you will use an alcohol with the 3 carbons. Yes, OH. Propanol will react with acidified KMnO4 to produce propanoic acid. If you want to make butanoic acid, again, butanoic acid or butanol will be oxidized into in the presence of carbon oxidizing agent to form butanoic acid. So this was the chemical properties of alcohol. Now, chemical properties of carboxylic acid. Carboxylic acid, this is a weak acid. And weak acid is an acid which is slightly or partially ionized in aqueous medium. Yes, Sarin will do macromolecules. Slightly ionized in aqueous medium. So what is weak acid? It is slightly ionized, and carboxylic acid, it's a weak acid. So this is a hydrogen which is behaving like an acid. This is H, which is behaving like an acid. This is ethanoic acid. If ethanoic acid or acid reacts with Mg or Na, when acid and metal, they react, what should be product? So product is when acid and metal, they react, product is salt and hydrogen gas, H2 gas. So their product is going to be the acidic hydrogen is substituted with Na. So this is negative and Na positive plus H2. To make it balanced, you will multiply 2, and sodium is solid. We call it sodium ethanoate. From ethanoic acid, it will form sodium ethanoate. And in a similar way, ethanoic acid can react with these reactants. This is ethanoic acid. If it reacts with calcium carbonate, what should be product? Complete this reaction. This is reaction 1. This is zinc oxide. What should be product? This is reaction 2. Number 3 is KOH. This is reaction 3. And here, this is reaction 4, reacting with Mg. Now write their products. You have only 1 minute for this. Yes, Amadali, sodium will replace 1 hydrogen, but hydrogen exists as diatomic molecule. To make it balanced, you'll multiply 2 and 2, and this is the balanced chemical equation. Yes. So products for these reactions, number one is calcium carbonate reacts with ethanoic acid, and product is going to be calcium ethanoate. So you will put bracket and calcium because calcium has positive two valency. Calcium ethanoate plus CO2 and water. When zinc reacts, so product is going to be zinc ethanoate, here too, and zinc plus H2O. When KOH react, it's going to be potassium ethanoate and plus water. And when Mg reacts, so this is going to be magnesium ethanoate plus H2 gas. To make it balance, you will multiply 2 and 2. There will be 2 Mg. So this was about reaction of carboxylic acid with metal oxide, alkali, and metal carbonate. And one last and important reaction, that is esterification. For esterification, alcohol reacts with carboxylic acid to form ester. Alcohol and acid, carboxylic acid, reacts to form ester and water. Ester and H2O. And this reaction is happening in H positive reflux. Now, for example, this is an alcohol which is ethanol. Ethanol will react with carboxylic acid, which is carboxylic acid. When a chemical reaction occurs between alcohol and carboxylic acid, from alcohol, H is given off, and OH from carboxylic acid, they form water. H and OH, they react to form water. So this is your product is going to be H2O. And this carbon forms a bond with this oxygen. So this is going to be C and O. And here this is an carboxylic acid chain, C double bond O and C. So this functional group is known as ester. And this reaction is happening in the presence of H positive and reflux. So how we can give name to this ester? First of all, you will give name to the alcoholic part and then carboxylic acid. So alcoholic part is your ethanol. This ethanol will be given as ethyl, and ethanoic acid is given as ethanoate. So this is going to be ethyl ethanoate. So this is the name of this ester. Plus water is byproduct. And again, if this is ethanol is reacting with propanoic acid. What should be product, and what's the name of this product when ethanol reacts with propanoic acid and you are doing H positive and reflux? Yes, Abdullah, ethyl propanoate. From H, go from alcohol, and OH from carboxylic acid, and product is going to be ethyl and propanoate. So this is ethyl propanoate. And one more thing I want to add at this point, this is ester. When you hydrolyze this ester, hydrolysis mean breakdown. Lysis mean breakdown, hydro stand for water. So hydrolysis is breakdown by using water. If you break this compound, again, you will get ethanol and carboxylic acid. This is ethanol and carboxylic acid you will get when you hydrolyze this ester, which is ethyl propanoate. So this was alcohol and carboxylic acid. Now let's move towards some questions. How many structural isomers with the formula C4H10O are alcohols? Now C4H10O, this is one compound. This is a trickiest question and most difficult question in the last year, 1, 2, 3, and 4. This is OH. First of all, you will change the position of OH. Here, carbon number 1 has OH. In the second structure, with the carbon number 2, there is OH. Now, these are the two isomers. And third is 1, 2, and 3. This is, you are going to attach at this carbon. This is number 3 isomer. And number 4 is 1, 2, and this. Here you have OH. So there is 1, number 2, here number 3. And number 4 is here you have this is methyl group 1, 2, 3, and this is number 4. So there are 4 isomers of alcohols, they are possible. Yes, Armaghan Chaudhary, hydrolysis में H2O use होता है, hydro stand for water. तो जहां से H remove होता है और OH remove होते हैं to form water, वहीं पे जाके वापस वो लगेंगे. अच्छा, now which statement about alcohol CH3, CH2, CH2OH are correct? So this is 1, 2, 3. This is propanol. When propanol is oxidized, it forms propanoic acid. Yes, this statement is true. Propanol burns in the air to form carbon dioxide and water. Yes, it's true. Propanol can be formed by the addition reaction between ethene and steam. When you add ethene into steam, ethanol can be formed. Ethanol cannot be formed. So this statement is wrong. So your answer is 1 and 2 only. Ahmad, that is not a reversible reaction. That it can be reversible reaction when you are giving them different conditions. So when you are going to heat ester in the presence of water and in the presence of acid, when you heat or reflux, so your ester will be hydrolyzed. Yes, you can say, but it depends on the conditions which you are providing. Achha, in the next is with this compound. I'm giving you 2 minutes to solve these two questions, 1 and 2. Propanoic acid reacts with calcium carbonate to form carbon dioxide and calcium propanoate. Oh, sorry. Yes, calcium propanoate. So what should be answer for this? So number A and B, they are how many carbons here? This is carbon number 1. Carbon which has CO2H, it is included in the chain. So there are 3 carbons. So out of these A and B, answer is possible. C and D, they are not possible because there are 4 carbons. This is carbon 1 and 3 carbons. So there are 4 carbons in this molecule. So this B, C and D is not possible. So here it is going to be C2H5CO2 calcium carbonate. So product is CO2 and water. So your answer is B. Hamad, A is incorrect because C2H5 and CO2 negative, it has valency of negative, and calcium has positive too. To write their formula, you have to cross multiply their valencies. So formula is going to be C2H5, CO2 negative, and here 2 and calcium. So this is a formula for calcium propanoate. So that's why A is incorrect, Hamad. Achha, question number 2. When ethene reacts with steam, ethanol, which type of reaction takes place? So this is ethene reacting with water. With one carbon, hydrogen is attached. With another carbon, OH is attached. So this is an example of addition reaction. Now, yes, what is the name of ester formed in this reaction? This is 1, 2, and 3. This is propanol. And ethanoic acid this is ethanoic acid. What's the name of this ester? So this is going to be, first you will give name to alcoholic part and then carboxylic acid part. So alcoholic part is ethanol and acid is propanoic acid. So your product is going to be ethyl propanoate. So ethyl propanoate is your answer B. Now, yes, do this. You have 1 minute for this. Yes, there will be same number of carbon atoms, but hydrogen and oxygen, they will be less because hydrogen and oxygen, they react to form water. So water is being removed, but carbon number remains same. So that's why carbon, hydrogen and oxygen, there will be less number, but carbon number, they will be higher. They will remain same, sorry. So what is the name of this ester? Now, how we can identify which one is alcoholic part and which one is acidic part? To confirm that the one which has C double bond O, that chain is acidic, and the one which does not has any C double bond O, that is alcoholic chain. So this is going to be propyl 1, 2, 3, and 4, propyl butanoate. Your answer is B. Now try to answer for these questions. As a solvent, we use alcohol, renewable fuel, and production of vinegar. So we use ethanol as fuel. Solvent, propanol cannot be used as a fuel. Which structure shows the carboxylic acid with the lowest relative molecular mass? The one which has smallest number of carbon atoms. So a compound which has smallest number of carbon atoms, that is, this D is not an acid, C is not an acid, and B, yes, this is an acid, A is also acid, but A has a lesser molecular mass. Now, ethanoic acid is formed. Now, do this question number 1 and 2, and these are the last question. Then I'll move towards polymer. G, for this, ethanoic acid is formed. Ethanol is reacting with acidified potassium manganate. So this is oxidation. For second structure of compound X is shown, this is an alcohol, which is butanol 1, 2, 3, and 4. Which statement is not correct? X is an alcohol because it contains the OH. This is negative charge. This is OH group. Let's check. X is an isomer of propanol. No. X would burn in air to form carbon dioxide and water. X would have a higher boiling point than ethanol. This is not correct. So X is an isomer of propanol. This is incorrect. Rest of the statements, they are correct. So your answer is only B. Now let's move towards polymers. Polymers, they poly mean many, and mers mean parts. So polymers, they are organic molecules which are consist of many parts or many repeating units. So we call them polymers, and repeating units, they are known as monomers. So how polymers are formed? There are two different types of polymer. Number one is addition polymer, and second is condensation polymer. And keep in mind, in addition polymer, only one type of monomer reacts. There is only one type of monomer. There is only one type of molecule they react, and monomer must have a double bond. must have double bond, because it's the trickiest part of this organic chemistry. And in condensation reaction, two different or one type of monomer, two different or one type of monomers, they can react to form a polymer, and they don't need any double bond, but they have alcoholic acid, which is carboxylic acid, or amine group. So condensation polymer exists between two different or one type of monomer. They must have, monomer should have alcoholic carboxylic acid or amine group. So they are in a condensation polymerization, only condensation reaction occur. Water is given off. Water is released, but in addition polymer, no water is released. Now, how addition polymerization occur? For example, this is C double bond C. This is one monomer. And other molecule of this is again ethene. So they will react. To simplify this concept, double bond will disappear. Simply double bond will disappear, and both the monomers, they will be joined together to form a bigger chain. This is one, and second monomer, 1 and 2, and both the ends, they will remain continue. So this is known as, this is polymer. And to give name this polymer, you will give name to a monomer, and before the name of a monomer, add just word poly. So this is polyethene. And if there is propene, this is C double bond C and CH3. Now you can see this carbon cannot form a bond. So for this to form a bond, single covalent bond can rotate or it moves downward. So C double bond C, this is CH3, and here this is. So this will form, just you have to disappear this double covalent bond, convert into single. So this is a polymer. So how we can give name this polymer? This polymer is made up of propene. So before the name of propene, we'll add a word poly. Now you have to draw polymer for these compounds. This is number one monomer. Second monomer is C double bond C, and this is CH3 and CH3. Draw the polymer for these two compounds. So again, double bond will disappear, and CF. I'm going to draw another repeating unit. This is second repeating unit. So this is addition polymer, and this is fluoroethene. Name for this polymer is polyfluoroethene. Now this number two is a quite tricky. Now you will rotate these two methyl groups which are present on the terminals, or which are present to the adjacent double covalent bonded carbons. So you will rotate them, and double bond carbon, they will come on the terminal or on the edges, and then you will convert them into a polymer. So this is polybutene. Now you can see in addition polymer, there is carbon-carbon single bond is formed, carbon-carbon single bond is formed, carbon-carbon single bond is formed. That is known as addition polymer. So this is the difference between addition and condensation polymer. But in condensation polymer, two different monomers like dicarboxylic acid or diamine, they react. This is dialcohol. Dialcohol is a compound which has two alcoholic group. And second is carboxylic acids. This is C double bond O and OH. This is C double bond O and OH. They react to form an ester. So from this side, H and OH, they will form water. So when water is given off to H2O, yeah, NH2O, so this carbon will form a bond with this oxygen. When there is oxygen or nitrogen is involved, that type of polymerization is condensation polymer. From this end, same and same. So this is here you have. And this is known as polyester because it consists of many ester bonds. So this is polyester. So this is example of condensation polymer. And instead of OH, there can be an H bond. So now let's move towards past papers questions because I have very short time. Now, diagram shows the repeat unit of a polymer, which to correctly identifies monomer and type of polymerization involved in this reaction. Yes, so there is carbon-carbon bond, no oxygen and nitrogen is involved. So this is a type of addition polymer. So what should be monomer for this? You will remove these two bonds and introduce a double bond between these two carbons. So this is going to be 1, 2, and 3. This is going to be butene. So monomer for this is C2H. This is a monomer, C2H5. There are two carbons and 5 hydrogen, C2H5, C double bond C. So this is an example of addition. Now, can you try with this same part of molecular chain is shown which monomer was used to produce this polymer. Now, first of all, identify repeating unit. The repeating units are, this is first repeating unit. There are 4 carbons, 1, 2, 3, and 4. This is second repeating unit. Number 1 and 2, they are same. This is number 3. So their double bond is between carbon number 2 and 3. So in the section D, here double bond is between carbon number 1 and 2. So this is incorrect. This has 3 carbons. So this is incorrect. 2 carbons incorrect. There are 4 carbons and double bond is at the center. So this is your answer. SN, it doesn't matter downward or upward because orientation of these carbons can be changed or can be different. So this doesn't matter because if you rotate them, they will come on the same position. Yes. First of all, you will identify a repeating unit. This is the repeating unit, very first one. This is number 1. And this is number 3. And this is number 2. These are the monomers. And they all are 1, 2, and 3. They are identical. So to identify a monomer, so it indicates there are 2 carbons, which has double covalent bond, this methyl group and methyl group. There is a double covalent bond between these 2 carbons. So this is hydrogen and hydrogen. So this is butene, 1, 2, 3, and 4. This is the structure for butene. Now, polystyrene is an addition polymer. The structure of this, what is the formula of monomer from which polystyrene is made up of? So again, identify repeating unit. This is first repeating unit, second and third. So from each side, break their double bond, and between carbon and between these 2 carbons, introduce a double covalent bond. So your answer is C6H5 and this C6H5 and second carbon has 2 hydrogens. So this is your monomer. Yes, it doesn't matter SN either downward or upward. It doesn't matter. Now, burning polymers can cause atmospheric pollution. Which polymer on burning could produce nitrogen oxide? The one which has nitrogen atom that will produce nitrogen gas. So nylon has amide linkage. This is polyamide, and rest of the polymers, they does not have any nitrogen, so they will not release any nitrogen dioxide gas. So the nylon has nitrogen, so it will release nitrogen gas. And diagram shows partial structure of a polymer. Which type of polymer does it represent? So first of all, identify the repeating unit. This is first repeating unit. In condensation polymer, double bond is not required, ISA. And this is second monomer, first monomer and second monomer. This is dicarboxylic acid and diamine. So this is an example of condensation polymer. And there is nitrogen, so this is known as nylon. This is polyamide. Nylon is polyamide. A polyester, this is not a polyester because there is no ester bond. Polyethene, no. Polysaccharide, no. So this is polyamide or nylon. Acha, polymer G has a structure. These four terms can be used to describe polymer. So again, this is dicarboxylic acid, diamine, dicarboxylic acid, and diamine. So this is condensation polymer, yes. This is polyamide, and this is not. So 2 and 3, they are correct. So this was about organic and mole. Now I'm going to give you my contact number. In case of any questions, you can send me a text message. I'll reply on your query. This is my contact number. And my name is. Send your problems on this number. I'll send your solution of your problems. In case of any question at this time, if you want to discuss, you can send me in the chat box. Iman Fatma, thank you so much. Yes, there was a question regarding mole. One student was asking me about that question. So, bache, send me your question in the on my WhatsApp number. I'll send the solution of that question to you. Yes, class is over. If you don't have any question, you may leave. Approximately 2 to 3 questions of mole from in one paper. Okay, bye. Generally, transition metals, iron 2, iron 3, copper, copper sulfate, and copper oxide. These are the colored compounds you need to remember. Compounds which you have learned in the salt analysis. But Hashim, before time, it's impossible to tell about threshold. So it's this is predicted after the paper. So I can tell you after the paper because I don't know which type of questions will come in the paper. Yes, Nasir Khan, question. Nasir Khan, this is my contact number. Send me your question on this number. Colors of metals. Bache, colors of metals, they are silvery or gray, but their compounds color are different. So all the metals, they are silvery in color. They are silvery solid except mercury. Yes, you should do practice as you can. For P1, at least you should do last 5 years questions, or paper one, you should do before to sit in an exam. Yes, but Sarem, due to the shortage of time, because I was planning for organic and electrolysis and some other topics, but in the start, students told me they have very weak part of moles, so I discussed moles first instead of electrolysis. Sarem, it's impossible for me before one day of a paper. In case of any questions, you can ask me on my WhatsApp number. Yes, any other question? Yes, I can show you regarding crude oil. Yes, this is a slide. Allah Hafiz, Hashim Raza. Okay, ji, Allah Hafiz. Thank you so much for joining me, and best of luck for your final exam. Allah Hafiz.